Hello on another Sunday fun day with Cosmos.
Alright, it's the Bangles.
Is that the Bangles?
Yeah, they
Sunday
had some.
Sunday?
Well, they had some
Hold on,
song.
you've got a little hair.
Okay. They had some Manic Monday. I think they called like Sunday was Fun Day.
Oh.
They listed. I don't know.
Okay. Well,
All
hi,
I know
Mom.
is just another Manic Monday.
There's another. Well, man, yeah, I've heard that. I don't know who came up with Sunday Fun Day.
You did.
Just now.
1985, September 9th.
That's
Came
what happened.
out. Sunday Fun Day!
But I think it was a Monday.
That you were born?
Yeah, so it might have been. So it was really more of a probably Manic Monday.
I think I was.
Monday Fun Day. Hi everybody! We got the usual suspects. The usual suspects have joined us today, which is cool. We've
Well,
missed
Federico's
everybody.
on vacation, so he has no excuse not to join us.
Except he's on vacation. Why would you?
This is the highlight of any vacation.
You don't remember, Mom? You don't remember the exact day, hour, minute, second of my birth? It was at 7:10 p.m. on a Monday, I believe.
You don't remember it. You don't remember it yourself. I was born at 5:59 p.m. Eastern Time.
Oh, God, how much does that bug you? That it was at a 59 mark?
I was
Ooh.
1 minute off.
Man.
On a Friday.
On a Friday, yes.
Yeah, so.
Oh, good. We need to do some cleaning. But,
Yeah.
why be productive?
I look at it and I just like, no, I don't want to.
I know. We got the dog hair, though. By the way, for those of you who are going to stick around for the hangover, which I assume might be...
Are you going to surprise everybody, or are you going to tell them right now?
I'm going to say stick around for the hangover. There will be a couple special features to show off. One of these Katie has seen. Don't give it away, Katie. But she's seen it. And it's just a little something that I've been working on. Jack was on a Friday at 1:32 a.m. on the day he was predicted to be born. Fulfilling prophecy. Jack Northrup, fulfilling prophecies.
I was born on the day I was...
Were predicted to come
predicted by my mom.
I was taken out on the day that I was taken out.
Yes.
I had to be physically removed.
So my mom, the doctor gave my mom the due date, and my mom early on was like, no, it's July 18th.
Wow.
She told the doc because she knew. I mean, she had it all. I was very planned, apparently.
To the T.
Yeah, so,
I like it.
yeah. So
I would think you would remember me getting C-sected out of you, Mom. I would think the
yeah, but
memory for
I
life.
was 6 hours away from, proving my mom wrong. I don't remember what date the doctor said. I should ask my mom if she remembers.
Can I, you got a little crusty in your eye. We've been watching The Sandman, so it looks like he visited you in your
We've
sleep.
been playing Elden Ring.
All right, I guess we'll get this party started. My mom's already got her drink out and going. Earl Grey lavender tea. So you took Jack. You're doing the lavender Earl Grey, like Jack had suggested. So I love it. Just drinks and people coming together, sharing ideas. It's wonderful. It's beautiful. It's a beautiful time. All right, well. Excuse me. Hold on.
We'll fix it in post.
Yeah, none of this preamble makes it into the
Yeah.
actual cut of the show. All right. Welcome, everyone, to Cosmos with Cosmos. As always, I'm Liz.
I'm Mike.
And I'm Gollum.
Smeagol is
It's
a Smeags.
He's happy. Gollum doesn't smile like that.
Everybody says Gollum, but
I
it's
know.
Smeags. This is the Smeags version of Gollum. Brandon's on assignment.
Brandon's on assignment, and
He's got to be on the ground by now, though.
I don't know.
He left at 8.
Yeah.
That was 6 hours ago. It's not that long of a flight.
Know, we're gonna find out that time works in weird, strange ways in this episode, because this episode we're talking about the Earth. The Earth has had its slowest day measured.
Shortest day
measured, atomically speaking. So that means we're getting into some atomic time. We're talking atomic time. Atomic clocks.
Yeah, and by atomically speaking, that shortest day was measured with an atomic clock. So
that's what it means, atomically speaking, because we're using atomic clocks to measure time.
Yeah.
Which I was... this topic came about based on an article that Mike had read and then told me about, and then I read it, and I was kind of blown away by it.
Yeah, I told you like the next day.
Yeah.
But I had thought about it, and I was like, this might make a good topic, but it's kind of a short thing, so we need to expand it out somehow.
Yeah.
And luckily that's why you're driving the car today.
We'll see what happens. Might go just straight into the hangover. But anyway, this is Cosmos with Cosmos.
Straight into the hangover.
So, what are you drinking?
I have to keep looking at the notes for my name, but I am drinking, I will hold it up, the Glacial Isostatic Adjustment, which we'll talk about.
I want to swim in it.
What? You do want to swim in it?
It just looks so pretty blue.
So, it's an ice-themed drink, but anyway, it has, alright, so it's supposed to have regular vodka, peach schnapps, blue curacao, and Sprite.
Curacao!
However, we have no peach schnapps. So, what I did was, just to hell with the vodka, I just went all peach vodka. Peach vodka for the vodka, and peach vodka for the, peach schnapps, but blue curacao with the Sprite. I was hoping the Sprite would make it a little more gradient-y, like
there's a little gradient
whiter
from the ice to the
a little whiter on top and a deeper blue on the bottom. But cheers, got a nice. Little peach flavor to it.
Nice. Well, I am drinking Laser Danger. Laser Danger. It is mango sorbet, white rum, lime juice, simple syrup, and some mango syrup.
Nice. And she made it.
I did. I made it myself today.
So we have a new bartender.
I was my own bartender. But anyway, of course, follow us on all the things at Drinking Cosmos on Twitter and Cosmos with Cosmos. Everywhere else, you find your media and your podcasts on the Spotifys and the Anchor.fms and the YouTubes and the Instas, and that's pretty much it. And of course, stick around for The Hangover if you're listening or watching this later on. Come back and check out The Hangover only on YouTube, as well as our short episodes called The Shot with Cosmos. Mike is not cooking now.
Very interested. All right, so Jack's like, add a little sugar cube to the vodka, change the density. That's a good one.
There we go. Let's get science.
No, I will not cook. She won't let me cook. Unless it's grilled cheese sandwiches, and that's it. That's all I'm allowed to cook.
It's not all you can cook.
That's all I'm allowed to cook.
You can cook. It's just I cook and he makes the drinks.
If I cook, she watches. Mentally grading everything.
I do. I got control issues. Jack, 87 degrees. So you went with a hot matcha tea, mint matcha tea. That seems still too hot for a hot tea, Jack, but nice. Mint matcha. I'm not. Matcha is definitely an acquired taste, and I don't think I've ever had matcha. I've had like a green matcha.
I don't think I've ever had
tea.
it. Whatever color it is.
My mom wished she wasn't allowed to go. Mom, you've done pretty good. You've made some good meals. You get that crock pot out. You do some good stuff. All right. Anyway, a couple promotions that we have to be made to our sponsors. Not our sponsors. But check out the amazing art of Katie Davison on Etsy, Wild Ixia. You can find her Wild IXIA. Check out Ron Proctor's YouTube channel or website, Mr. Proctor Show. He makes some cool cigar box guitars. He plays them. He talks about education, political commentary. He's got a fantastic mustache.
Okay.
So check him out. And also check out Jack's Planetarium, rollingbluffsplanetarium.com if you're in his neck of the... Are there woods?
It's very flat there.
Yeah, I would say if you're in his neck of the plains,
go
in
visit.
his neck of the plains,
and go visit, and check out the wonders of the universe from Jack.
But in the meantime, while you're joining us here, we do have some rules. If you hear some dogs barking, take a drink. If we make any Star Wars or Lord of the Ring references from this point forward, take a drink as well.
Why did Smeagol get all blown out all of a sudden?
Oh, because you moved him.
Did I?
Yeah, and so he's getting more sun. He was positioned appropriately so that he was turned so that he wasn't getting hit with too much light. Aw, Smeegs. Anyway.
All right, let's get it going.
On with the show. Let's start this. My drink's sticking to the napkin that we got here. The Earth had its shortest day ever measured, and it was
measured. That's the key word.
Measured
in recent, since the 1820s.
In recent history, and it was 1.59 milliseconds shorter than it's supposed to be, or has been in recent recorded history. Holy crap! Are we dying now?
Well, 1.59 milliseconds doesn't really... We don't feel that, right? But
no.
But the thing is like, so the Earth, since the 1820s, since we started doing this measurement thing, has been slowing down. And we know about this. We know that the moon is slowly pulling away from us.
The moon's really just dragging us.
Yeah.
Dragging us down.
It's literally, because that's what's slowing
Friction.
us down. And so the moon slows the Earth down. The moon, as a consequence, because of the conservation of angular momentum, the moon pulls away because the Earth slows down. And so we know about this. But here in recent times, so on July 19th of 2020, there was a record set for 1.4 milliseconds that the Earth spun faster. But on June 30th, June 29th, it actually broke that record by 0.1 almost 0.2 milliseconds.
Wow. That's, it seems minuscule, but it also seems pretty significant because you wouldn't think that you should, in such a short period of time, that you would have.
And there's... Now, astronomers don't have a full understanding of why, but they have a really good idea of why, which we'll get into.
Before we get to that, let's talk about how we're measuring time, right? Because how it's like the capability to measure to such a small fine degree. Like, that's not something like, let me get my Fitbit timer out and start measuring the length of a day. I mean, you need some really precise technology. In ancient times, people told time by looking at the stars and measuring basically the movement of the stars across the sky and the seasons in order to get, a 24-hour day, a 30-day month, that sort of thing. Or month, if you could buy a moon cycle.
And sundials.
And sundials and all these things. And it really, and then you have the development of, like, mechanical watches and, clocks that I didn't really think about how a clock worked before. So, like, my family, we have this old pendulum clock. And I never really thought about, like, that the pendulum was actually the mechanism of how it keeps time. That pendulum, that swing is a second for it to swing, and that gravity, temperature, all these just natural conditions will actually change that pendulum's ability to measure that second and then
Right.
throw a clock off. And the way a clock needs to work is it needs to have this
Needs to have an oscillation.
it needs to have an oscillation to set that baseline of basically like what a second is. And so over time people will develop different things that have better reliance of oscillation. I don't know.
Yeah, so with quartz.
Quartz becoming the next step up.
Yeah, so like I think it was the 1920s, I believe. Anyway, 100 years ago.
Mommy, we can't see you. If you raise your hand, we're not gonna know. Just chat it out, and then we'll see it eventually when we look at chat.
It's actually kind of fun.
I can just see my mom in the recliner at home, just like, guys, me, pick on me.
Okay, that's good.
But
That's good.
she said the Sumerians started how we measure time, and we still use it.
Yeah, was it a 24-hour day?
I thought the Egyptians gave us a 24-hour day.
Somebody way back then.
Yeah, those ancient
neck of
people,
the
they
woods.
started it, and then eventually we've refined it.
Yeah, so you can with a quartz crystal, you can get it oscillating, and it has a property of being piezoelectric, is what you wanted to originally.
Oh, that's right. That was my original
name.
drink name.
Yeah, but Laser Danger is fun.
I like Laser Danger.
And that piezoelectric quality when they vibrate, when they flex, when they bend, but really vibrating, which is really flexing, but it actually builds up this electric charge, and you can send that out, and that's
what drives
that's what drives your clock.
the clock mechanism to keep going.
But in the 1950s, and that worked beautifully.
It still works. I mean,
it still works.
It's still something that is
it's in a lot of people's watches and stuff.
mechanical watches.
And if you see quartz on the watch,
Then it uses.
That's
That's what
what
it
it's
uses.
using.
And I didn't know that before. That if it says quartz, is because it's
Yeah.
using a quartz oscillator.
yeah. So
I didn't realize that.
and so in the 1950s, though, we really needed to really kind of unify timekeeping around the world. There's a lot of things that really relied on it with
more precise measurements.
more
of
precise.
time.
You had people traveling all over the world. The world became really
Interconnected.
Interconnected and smaller.
Trains needing to
Planes,
get from one
automobiles.
city to another across countries. They need to have their times synced up and accurate.
Right. And so in the 1950s, they started working on atomic clocks.
Which is, I mean, first of all, this sounds like some sinister mechanism of an evil villain
it does, right?
building an atomic clock to take over the world.
Supervillain would use an atomic clock.
An atomic, or it sounds like something that goes on like a nuclear bomb or something. Like it's the clock that, the detonator to a nuclear bomb or something.
Right. Yeah. So they started working this out, and so basically we needed to develop quantum physics to be able to understand the idea of a quantum clock. An atomic clock. And basically, atoms oscillate. Basically, they oscillate. They oscillate in a very,
Vibrating. This is my depiction of an atom vibrating.
Yeah.
You can't see it if you're listening on the podcast, but I'm just vibrating.
It's freaky. And so they oscillate in a very predictable manner. And so technology got to the point where you could measure that, and if you can measure it, it becomes a clock. You can turn it into a clock. And in the 1970s, they actually met someplace over in Europe, I think. But
Yes.
they met and actually figured out what atom they were going to use. Cesium.
Cesium-133.
Yeah, cesium-133.
It
is
has
the atom.
9. It's like oscillation frequency or whatever is like 9 billion something
tons per second.
So the higher your oscillation factor frequency, then the
Frequency, that's the word.
frequency, then the more accurate your clock can be. And so like it's where they of course all of these things, the quartz, even atoms, there are natural effects that can disturb that, but like for an atomic clock, using an atom like this, it could take like 2 universe lifetimes to lose a second, right?
Lose a second, yeah.
To lose a second. So
yeah,
it's going to be pretty accurate for a long time.
Yeah, so if they had started these cesium-133 atom clocks at the time of the Big Bang, which you couldn't, by the way, because there was no cesium in the universe at that time.
Oh, you need stars go boom.
We need stars
You
go
need
boom.
stars go boom.
But let's just pretend. There was one lone cesium.
Well, just one. Just one little.
Hey, I did it. I got made in the Big Bang. And so it would be off by less than a second today.
Wow.
That's crazy.
Jack says Harry Belafonte's lesser known B-side, Shake Your Atoms.
Shake Your Atoms. Yeah. And so basically they've been using atomic clocks now in a bunch of things, but
one thing that I found interesting that I didn't realize because I didn't really know, like I knew there were atomic clocks, I didn't know they were really used for anything. Like I thought they were just like part of experiments or just something fun to do, like, oh, we're keeping a super accurate time of the Earth or whatever. But GPS relies heavily on the use of atomic clocks because because they are triangulating locations, and if they're not synced up, if they're off by just a second, then like if you're using Google Maps, your positioning will be off by 300 meters.
Yeah,
I don't know what that is in feet.
It's 3 football fields,
but
roughly.
It would actually be a significant distance that you're off.
Right, but it is if it's off by like a microsecond, and so that time is the key part there.
Yeah.
And so if the signal's off by a microsecond, you're off. You're going to be off by 3 football fields. But if they did not have atomic clocks, you would be off by something. What did they say? It was something like
6 miles or.
Yeah, but it was something. I can't remember the length of time. It was something. It was less than a second, or I think it was less than that. Whatever it is, but at the end of the day, your position you would be 6 miles off from where you
where you should be,
right.
Where you should have been. Like that's significant. Like we couldn't have GPS working without atomic clocks.
Exactly. And so they're using these atomic clocks to measure the rotational speed of the Earth.
My mom asked, where does her Fitbit fit in?
I have no idea. It uses GPS.
It uses GPS, so it's relying on those GPS satellites to use their atomic clocks
have the atomic
to
clocks.
triangulate, where you are in your run.
Yeah, but I don't know how the Fitbit works in, to all this. But anyway, so on July 29th, they measure that the Earth is 1.59 milliseconds faster in its rotation. To put that in perspective, 70 million years ago when dinosaurs were around, the day was 23 and a half hours long. So we've known that it was slowing down. But now it's speeding up. And if this trend continues, we've been adding leap seconds every so often. If this trend continues, we might have to take away a second just to make everything sync up. And that would be in the next 3 to 4 years that we would need to do that.
Yeah, because it's not supposed to. It's supposed to keep slowing down.
Yes.
Based on the Earth should just be slowing down because of the drag of the moon and all this stuff.
So,
like it's not supposed to be speeding up. There has to be a cause.
Question is why.
Which this is what I was like, wow, this is interesting, and the why is kind of like something that I don't think most people would even think about as an effect.
So, just for a moment, I want you to think about, I know there's only 2 data points, but think about the record is June 29th, 2022. The previous record was July 19th, 2020. What do those have in common? They have in common that they're in the summer months for the Northern Hemisphere.
It's hot.
It's hot.
It's getting hotter.
And these are in recent times. And they think that the reason why that the Earth is sped up is because of climate change. Now, just think about that for a second. Think about it. The shit we're doing is not only affecting life on this planet, it is affecting how fast the Earth spins. So, now before you go, what? Why? Why is that happening? Let's talk a little bit about the Earth. The Earth is actually a little bit wider than it is tall.
It is an oblate spheroid.
Yes, that's exactly what it is.
Like
So it's a little bit wider than it is tall. Basically at the poles, you have the polar ice caps. Ice is heavy, and so what that does is it pushes. It's basically pushing down.
It helps create that oblateness.
It helps create that oblateness.
In the middle, popping out.
So
Top.
what is happening now is that ice is melting extremely fast, and so it releases that weight on the poles, and so the poles actually they get higher. Is that the right
so
word?
Earth kind of like, it makes the Earth less oblate.
Yeah, it makes the Earth less oblate, which moves that center of mass closer to the actual center of the Earth. And it is like a ice skater that is spinning when they have their arms
We've
out.
all seen that, and then they put their arms in, and they go super fast. And you're like, oh gosh!
Yes, and it's because it's most likely because of climate change.
Wow, I mean that's crazy to think about. That just the melting of just an enormous amount of ice that is not supposed to be melting at the rate that it is.
Right.
Is actually speeding up the rotation of the Earth.
Yeah, and what we have known about with that melting of the ice is we have known that that the poles were going to get higher. We've known about that because the ice melts. It releases that weight. The poles get higher in elevation, and that water goes down, and it doesn't really affect the coastlines of the North and South Pole. It affects the coastlines near the equator. And so because they go up and down, the poles do, they go up, and all that water gets basically kind of pushed towards the equator. And that's why all these little islands near the equator are really fucked because of it. But it's not an even distribution when the ice melts.
No.
These poor island nations around the equator are affected more than the countries near the poles.
Yeah.
But I don't think that they ever really thought about that the Earth was going to spin faster.
Yeah, like that. When I was reading the article, I was like, I never would have thought that climate change would affect the Earth in that way. Like you think about it affecting the storms and sea levels and that kind of aspect of it, but not the actual physical movement of the entire planet.
Exactly.
And
your mom
otherwise it could be just as Jack says. This is the only other reality that could be happening, is that millions of frat boys went out and farted in the same direction and they sped up the Earth. That's the only other plausible explanation other than climate change. And I can see them doing it. Oh, but they'd have to be it's really only American ones, I think, would do that. Maybe some UK ones, actually.
No, it's the American ones.
But my mom asked, how do they know from the Jurassic area that the Earth was going faster?
You can look at the fossil records. The fossil records, like there's fossils. I think you look at like various animals. They lay down like a certain amount of their shell or whatever every day, and you can actually you can measure that type of the Earth's rotation based on that and other things. So it's all based in science, and it's not.
That's pretty cool.
Yeah.
And also you can look at just how just the formation of the solar system and how other planets are rotating, and then with the mass of the Earth, the mass of the Moon, and how much drag it can pull, and then kind of subtract backwards in time when the Moon was closer, and how much drag it would have, and kind of.
Yeah, and so you can make predictions based on just the physics of the situation.
Contextual physics.
Yeah, and then you start comparing that to like fossil records and the records and rocks and stuff like that. And you okay?
I just had like a hair that was like sticking to my nose and tickling me.
And looking at rocks is how we can find out, that the Earth's magnetic field flips, and all this kind of stuff.
That's how looking at rocks is how we know that like Mars had water in the past and was
There's a lot of
habitable.
shit you can.
Like
There's a lot of stuff you can figure out.
Rocks, man, rocks are key.
Yeah.
Rocks are key, really. I mean, just looking at just elements.
I don't know if
stuff.
I'd want to be a geologist, but rocks are kind of cool.
I do like looking at strata. Like when we're driving and we see like the strata in the in the mountains and stuff.
Yeah,
and I like looking at strata patterns.
I like to see the strata that it goes like up.
Yeah,
because some shit happened to make that strata go instead of like horizontal. That it's like at a severe little angle.
The color changes, and these are like different periods of time. Anyway, I mean rocks are pretty fascinating. My mom also asked, does that affect gravity? Earth rotating faster, which I would think it's not, because gravity is based on mass. Gravity is based on the mass of the planet, so it doesn't matter. Like if I spin faster, I'm not gonna weigh less. If I spin faster on Mars, I will weigh a little less. Because Mars has less gravity.
Yeah. But no, it won't affect the gravity. But what? Unless you're at the pole, and then there will be a little bit of a gravity change.
Oh, because you're a little bit further. You're a little bit further from that center of gravity.
Yeah, it is not much. It's minuscule.
It's very minuscule.
It's very minuscule, but it will be.
I mean, 1.5 milliseconds is not something we're noticing on a.
And remember, that is just one day. It doesn't mean that it's consistently 1.59 milliseconds shorter.
That's a good point.
So, is the Earth spinning, speeding up? Possibly. Climate change is going to remove a lot of ice from the poles in the next 100 years. So it'll be really interesting. It's going to be really interesting to see. And there's just so much evidence for it.
Yeah.
I don't see how anybody can put their heads in the sand anymore.
Yeah.
And I'm really glad that like people are starting to call it climate crisis, because that's exactly what it's
becoming. How long? I don't know how to ask this question. At what point does the Earth slow enough where it actually affects us and ecosystem? Because there's a lot of species that rely on the constant, like the cycle that we have, the day and night cycle, the rotational period of the Earth, and agriculture and all that kind of stuff.
I would think that the timelines we're talking about
are
very long.
Or possibly not ones that we could maybe survive through.
And so evolution has plenty of time to work out the details.
Adapt
to it. And but
evolve.
To evolve. Yeah, exactly. So it'll be interesting to see. Like it'd be really cool to come back 3 billion years from now before things get really hot and see how life is adapting to the longer days. It's gonna be a much longer day. So.
Mom says she was thinking once it speeds up, it stays at that rotational rate. So it sped up, then slowed down to where it usually is.
Yeah, it's gonna have to slow down. It's gonna have to slow down. I mean, because it is losing that ice, but
you still also have the factors of like the drive for the moon and all that.
Yeah, there's a lot of stuff that's going.
So it's gonna be. It seems like it is like something that is variable.
Yeah.
Based on conditions. I mean, if we completely lose our polar ice caps, which yes, bad news bears everybody. If that happens.
So the record was June 29th. I mean, obviously, what's the next day? June 30th. Came in a little slower. And it's been slower than that ever since. But
I wonder if then there was like, oh, that day, it was like the culmination of just a massive ice loss,
Yeah, because they do. I mean, this is the time we're setting records for ice loss and Greenland, and
so it could have been like there was a massive amount of ice loss that day,
and it affected things.
And so it showed in that atomic time measurement.
Yeah, so it the thing is like.
Oh, you got an ad played during our video? Wow. I didn't know that happened. Okay.
Wow, that's weird.
Hey.
Anyway, so where's our money, YouTube?
Give us our money.
There's a lot of stuff that's going on. We're losing ice. We have magma that's moving around. The molten core is kind of moving around.
Sloshing.
So there's a lot of stuff that's going on. Mm-hmm. But a lot of this magma and molten core stuff is already kind of accounted for.
Yeah.
So this ice loss is what is what kind of maybe pushes it over the edge. Mm-hmm. Again, this is just kind of what they are really leaning towards as the possibility.
I mean, it makes sense.
It makes perfect sense.
And I don't see that. I mean, I really don't, other than the frat boys, Jack, I don't see what else could contribute to such a degree of time.
Speeding up?
Yeah.
Yeah.
I mean.
I am actually now interested in maybe tracking this. Mm-hmm. So. There's all right. So I did some science this week with Skittles.
He did. He got a bag of Skittles, and actually did some math with a measurement in a shot glass.
Yeah, and I found out that my calculations were spot on.
Math works, everybody.
Yep. So I was really happy about that. But anyway, there's a few health things I have to track, but it might be kind of cool to just like kind of track this and see how it's going.
Uh-huh. Well, I just find like. The concept of an atomic clock, and even the concept of like...
You're really fascinated by the atomic clock.
Yeah, just like deciding
because
what a
this is the one thing
is.
that she's really latched on with this story.
The atomic clock.
It's the atomic clock.
Yeah, and an atomic clock doesn't look like a normal clock. Like it doesn't have hands and ticking away. It's a bunch of lasers. It's laser danger, everybody.
The modern one.
Yes, the modern one. Yeah.
And by modern, I mean the 2020 and not the 1950.
So the most accurate atomic clock is at the University of Colorado in Boulder,
right?
From a group called NIST, which I can't remember what the acronym stands for.
What it is. National
NIST.
National
NIST.
Institute of Standards and something.
Time? I don't know.
I don't know.
I don't remember. But NIST, and so they have the most accurate atomic clock. Well, what do they use? Cesium or?
They weren't using cesium.
No, they weren't using cesium.
They were using something else. Strontium. Strontium is what they were using.
Strontium. Okay, so they were using a different atom to oscillate, and it's like you. And in the video that we watched that actually highlighted this specific atomic clock, like you could show like you saw like it was like millions of atoms of this
strontium.
Strontium that was like little like blue, and then you have just all these fucking lasers going through these lenses and being redirected and all this. It's like this crazy contraption that its sole purpose is just measuring time.
Yeah, so the lasers, what they do is they stimulate the strontium.
Yeah, so it gets that oscillation.
It gets the
so
oscillation.
So it creates that energy to vibrate it at that certain frequency.
It has, that's the word. It has to be at a very key certain frequency.
Uh-huh. Because, and those oscillations, they can degrade, and so the lasers will add that extra energy to keep it going, to keep it at that rate, to keep it on track, to keep it on time.
It's a correcting
It's
system.
a feedback loop.
Yeah, it's a
It's a
feedback loop.
feedback
It's
loop.
a self correcting system. So if the oscillation gets too slow, the lasers immediately make it a little bit higher, and then drop it back down. But the lasers have a specific frequency. So once you start hitting them with that laser and you get that frequency, you're basically you're golden.
It's predictable. It's a set thing. And
Yeah.
so it's crazy that we've first figured out how lasers
Quantum
are,
mechanics.
and then we're like, hey, let's take millions of atomic particles of an element and vibrate them, and we can tell time with it. It's a bruise. I ran into something. I don't remember how that particular one happened.
Sorry, we broke down the show.
I have bruises just everywhere because I bump into things.
Yeah, I
I
mean,
bruise easily. Katie knows.
Lasers. I mean, you can't have if there's any proof that quantum physics works.
Lasers.
You can't have
Lasers.
lasers with a Newtonian way of looking at the world. You have to have quantum physics, and yeah, it's just it's insane. And I am really loving that you have latched onto atomic clocks.
Yeah, it's because I guess really you see Katie knows bruises. I guess talk of atomic clocks. Just for me in my mind, and just whenever I've heard, it's always been kind of like a science-y fiction-esque thing, not real, or it's something that's very it's not.
It sounds very futuristic.
Yeah, and it's something that's not it's not like a used thing. It's like a flight of fancy, or just hey, we have an atomic clock and we're doing experiments. But it's actually something that is necessary to our way of life. And us being able to function as we do now in the technological world that we've developed. And it's just crazy that we can tell time just by vibrating shit we can't see.
I know, right? Yeah, and obviously in our everyday world we don't. Okay, let me phrase this. Let me rephrase this. In our everyday world, in the contraption that we have on our wrist, we do not need the precision that atomic clocks will provide us.
No, we don't need to know.
But
I'm late by 1.59 milliseconds, everybody.
Yeah. Goddamn Earth.
Shit.
It's the Earth's fault. Yeah, but in science experiments now, we do need this.
Yeah.
CERN needs it for their experiments.
Bumping
those protons together.
They need to time that pretty fucking perfectly.
Yeah, and I mean we do need it for GPS, but in science experiments now, atomic clocks generally are really quite useful because of the precision that it gives us on time.
And what has been really helpful also with atomic clocks, starting when they first started making atomic clocks, was being able to understand time dilation. With Einstein's general theory of relativity, where if you are, higher in altitude above, further from the center of gravity, time actually slows down, speeds up, slows down, speeds up.
It speeds up.
It speeds up.
The further away.
The further away, time speeds up, and they were able to actually measure this incremental difference.
Yeah, so
just by putting an atomic clock on a plane and having one that uses the same element of oscillation, so they should be in time with each other.
Oh, yeah, no, they are.
They
completely are.
But on sea level, they noticed that the sea level one, the one that was on the plane, ended up ticking just a bit. I say ticking lightly. There's no actual ticking, but faster than the one at sea level.
Right. So, all right. So there was a lot of stuff going on with the plane, but in the 1970s, these two physicists got two atomic clocks, because you never just do one measurement. You do
gotta
two.
have multiple data points.
So they put two atomic clocks on a 747 or something like that. I think it was like a Pan Am flight, and they flew they're in like suit and ties.
Of course they are. It's the.
Meanwhile,
what,
I'm
60s,
gonna be
70s?
in my fuck Nazi shirt and
You're gonna be in your airplane clothes. You're gonna have
Yeah.
comfy airplane clothes.
and so it's they flew it, and there's two things that go on with this. First of all, you're moving pretty fast. Okay, relative to our everyday experience in this plane, very slow compared to the speed of light. But the atomic clock is actually able to measure the time dilation for that speed. But also, atomic clocks can be used now to where we can measure time dilation just by moving an atomic clock
A
up
centimeter.
at 1 centimeter.
1 centimeter above another atomic clock, it can measure that time
That
difference.
time dilation. So when you're at sea level, time moves at a different rate than if you're on top of a mountain.
So like our time is moving ever so incrementally slower than say someone at sea level. I don't know. I can't
Okay,
name
no,
a
you
place.
got it backwards. So
Or
our
faster.
Yes.
I can't. My brain can't wrap around time at all. Like it doesn't. Like this doesn't. I can't. I just even thinking about if you're moving at the speed of light and your time moves so much slower for you.
was, yeah.
That it almost seems like it's not moving. Like I can't.
Right.
My brain is like, I don't have any contextual basis for this, so it can't really resolve it. Like, it doesn't make any sense, even though it works. It's a thing.
We should do a show on relativity and time. But all right,
That's what we're doing right now, basically.
Well, yeah, but we're all right. So for us here in South Ogden, in the beautiful American Rocky Mountains, we are something like 5,000 feet above sea level. So let's just say 5,000 feet above sea level. So time moves actually faster for us than it does for somebody at the beach in Hawaii. And so, but if you're in Hawaii, you do want time to move a little bit slower.
Yeah, you
so
definitely
this is what I suggested to Liz today was that Monday through Friday, up until 3 o'clock, because that's when I get off generally work, but we put a clock as high up as we possibly can, so that it moves faster, so we can get through the work week.
Put our computer on a shelf.
And then
I'm off now.
And then, as soon as we hit 3 o'clock on Friday, we just dig the deepest hole ever and
All
put
right.
the clock in there.
Like, oh no, sorry guys,
Sorry,
I'm still
Greg.
on weekend. I got 0.001 seconds left before I have to start work.
Yeah, but it's true, and it's measurable. It's measurable. We can measure these things now with atomic clocks. And if you move a clock up 1 centimeter and time moves faster by moving it up 1 centimeter for gravitational purposes, in gravitational time dilation, that means that your head ages much faster than your feet.
Your head's older than your feet.
Yeah, it's older than your feet. Generally, because your head's usually
Out
above
first.
your feet.
Oh, yeah.
Outwards.
I said out first.
Oh. How much alcohol did you put in that thing?
I didn't. I'm really not. This is just
so
just who I am.
This really is. It's a mind-bending shit. It really is mind-bending
is.
stuff.
It is.
And actually, really and truly, we should do an episode dedicated to relativity, because it's really it's just crazy shit. So, relativity. Einstein really dreamt this shit up in his head.
It's a thought experiments. All he had was thought experiments.
Yeah, thought experiments. And so I had actually known about some of his thought experiments. There was one, it's like, I'm on a train. A lot of them involved trains.
Wow.
Because he would get off from the patent office and then he would take a train home. And so one of them was like, hey, if I shine a flashlight Can I ever catch up to the photons? And the answer is no, you can't. Short answer. But in this one, I had not heard about this thought experiment, and this is the one where he figured out that time stands still if you're going the speed of light.
Yeah.
And it just made perfect sense to me hearing about it this morning. Was that he was on the train, he was looking at the big central clock in Bern, Switzerland, and he just thought, what if I'm going the speed of light? What would the time be on the clock? Well, it wouldn't change, so time would stand still for him going at the speed of light. I mean, there's other issues that you have to overcome, but
traveling, getting to the speed of light.
Getting to the speed of light, but
not being able to see the clock anymore because you're moving at the speed of light.
Yeah, but basically, I mean, yeah, time stands still, and he thinks this stuff up on a train. Mm-hmm. Then there's the whole rigorous thing of I have to mathematically prove it.
Right.
Because you can come up with shit.
Oh, yeah.
Like I can say that there is an all-intelligent being that created created life on Earth, everything. And that,
you gotta prove it, and also prove it mathematically.
And you gotta prove it mathematically. You gotta be able to make predictions. And by the way, that is a true statement for some people. It is called intelligent design, and so they try to put it on the same level as Big Bang, but it's not scientific because you can't prove anything just because of the way they say it.
Also, I have immediate proof against that. Balls on the outside of the body. Not smart, not intelligently designed for the amount of pain it supposedly causes.
Oh yeah, I mean amount of pain, yeah.
Jack says, so when you take a nap, you are syncing your brain with the rest of your body. I think I had that yesterday. I took a nap, nicely synced. But then as soon as you get up, Jack, unsynced. Immediately.
And I let you sleep.
You did, thank you. My mom asked, is there a way to check rotation variations of other planets? Well, we would have to put an atomic clock on
I think at this point
planets. But we do know that other planets, we know the rotation rates, and we know that, like, say, for gas giants like Jupiter, Saturn, Uranus, and Neptune, and also the sun, they do have their poles rotate faster than their equators.
It's called differential rotation.
And they are also oblate spheroids.
Especially Saturn.
Especially Saturn is puffed out at the middles.
Yeah. More. It's like me. I'm an oblate spheroid. I'm working on that. I've done pretty well, but here lately. But I'm an oblate spheroid. I'm Saturn, everybody.
Oh my gosh. Well, you got a ring on it, so. For solar system rotations, since you asked about rotations, the sun's rotation is 25 to 34 days.
And that shows the differential rotation. So the 25 is at the equator, which spins faster.
Mm-hmm. And the poles are slower. Mercury is approximately 60 Earth days long. That is a slow-ass fucking day.
This is even worse.
Venus is 243 Earth days long.
And that's as measured by the stars. Not by the sun, but measured by the stars. Its day is actually longer than its year.
Yeah, that's right.
227 days for it to go, or something like that, to go around the go around the sun.
The moon's rotation is 29.53 days, also known as a moon. I will always do the joke every time because it's fun to say moon.
But it's so fucking true. I mean, that's where it comes from.
I know.
That's where it comes from.
The moon,
even though only February once every 4 years actually goes, hey, we're gonna do that in 29 days.
Yeah, get an extra day for you. Mars is very close to ours, 24 hours and 37 minutes.
Yep.
Jupiter is 9 hours and 56 minutes.
The fastest.
The gas giants tend to rotate faster. Saturn is 10 hours and 34 minutes. Uranus is 17 hours and 14 minutes. Neptune is 16 hours and 6 minutes. And Pluto, not a planet, but we'll include Pluto for posterity, 6.4 days.
You know how long it takes for a Charon to go around Pluto?
No.
6.4 days. They're tidally locked.
Oh, that's right. They're tidally locked.
Yep. So, which I really think is cool. So, like, you know what is really cool about it for me though is like you're at a certain place on Pluto, you see it all the time, it's always there, but then you go on the other side of Pluto and it's not there. You never see it. Like if there's like a little deer that
you
lives
wouldn't know
on
it existed.
Nope.
You would never know unless you traveled to the other side. Jack says Sunrise Sunset is a long song on Venus. But on Venus, though, the carbon dioxide clouds are so thick that you're really not going to get a sunrise sunset. I mean, you're not you don't even, can you even see the sun through those clouds?
You're fucking dead anyway.
I mean, well, yes, sulfuric acid rain, crushing atmospheric pressure, 900 degrees Fahrenheit, like always. I mean, you're not surviving.
Yeah, there was a story that I read when I was a little kid about Venus. And so, this is so unrelated to anything.
I'm sorry, I was looking at my mom's.
Well, no, I mean, it's completely unrelated. But, so the story was about this little girl who was so excited to be able, because the clouds were going to part. She was going to be able to see the stars for the first time in her life, because it only happens every so often. And she was so excited, and these bullies put her in a closet, and she missed it. But I just always remember that story, maybe for the sadness of it for that little girl.
I've never heard any story like this.
Yeah, and I don't remember how old, I know I was a kid, but I don't know. It was a short story. It was a short story, but yeah, and but it also shows, I think, how we used to think Venus was, which was a tropical paradise. And it's not
tropically deadly.
Yeah, it's
my mom says, would I be younger on Venus then, longer to get my birthday? Well, no, its year is shorter than our year, Mom.
Yeah, and so you would have more birthdays, but time would go just a little bit slower. I mean, faster. No, it's less gravity. It would go a little faster for you.
Yeah, so if you want less birthdays, you want to go like
go to
Mars, Venus.
Go to.
I'm not Jupiter. Venus, Jupiter. You never have it. What's
I don't know where you're going.
I don't remember the orbital rates of all the planets.
Oh, Jupiter is about, what is it, like every 12 years?
Yeah, so a birthday every 12 years.
I know. I was when I was putting the rotational rates down.
Unfortunately, your biology is going to have you age the same.
Yeah, when I was like oh shit. When I was putting the rotational rates, I was like, God damn, it's been so long since the Given Planetarium show.
I know, it's like those just those little easy to look up facts that don't really stick in your brain because they're just kind of that little stuff.
Yeah, so I mean Pluto, the less mass, the faster time goes. So Pluto's really gonna fuck you. The moon. But
the less mass, the less you weigh.
Yeah, so...
Win-win? Well, win-lose? Lose-win?
Well,
it depends on what you're looking for.
It's a lose-lose.
It depends on what
It's a lose-lose. You lose the weight and you lose the... Hey, but you know what? You do live to like 200 years old or something.
Hey,
no, actually, you don't even make a birthday. You don't even have a birthday on Pluto.
No, you never have a... No, so really...
You only make it like a quarter way around and you're like,
on Mercury... You get multiple birthdays. You get you get a birthday every 80 days. 80 days? 88 days?
Yeah, something like that. 88 days, yeah. But time moves slower. Faster on the surface of Mercury, but you are deeper in the sun's well. So, gravity well. And so maybe you're getting a little boost from maybe a little bit of slower time from sun.
Also, you're either real hot or real cold. So...
Yeah.
And there's no atmosphere. So really.
Okay, skinny. It's not skinny.
No.
You still have the mass.
Yeah, it's just the pull of the planet's mass is less on you.
You still have the mass.
You still have the same everything.
So I look like this on Earth. If I go to Pluto, I look like this on Pluto. I look the same. I just
frozen to death.
I'm frozen to death.
But the bottom line is, none of the other planets are gonna be great because you can't live on them and survive in any way, shape, or form. So, I mean, Earth is in our solar system. Earth is the best planet to be on for habitability wise.
Yeah. But I think this one headline
Just this one.
just it really shows how much we. Okay, so to be honest, we get overloaded on all the headlines and on all the news, and it's never good news anymore when it comes to the climate.
No.
And what really just fucking grabbed me about this was that the reason why they think it's happening
is because of us.
is because of us.
Shit that we've done.
It's not only because when we read articles about climate change, and I'm going to be the first to admit that I read the things that just depress the shit out of me. Roe v. Wade, climate change, all the politics.
Every now
Why
and then
are
you just
yawning?
gotta.
This is an amazing topic.
It is.
And so I've read all these articles about how we're basically have initiated the next mass extinction that's going on.
Yeah.
Sea levels rising,
California's
all this
due
kind of
for
stuff.
a mega fucking flood.
Yeah, and which one? What?
California.
Oh yeah. In the next 100 years, there are going to be mega floods in California that will flood out all of the Central Valley of California, which is huge.
I mean,
which is Massachusetts and Connecticut combined.
As someone from California, Central Valley is, they can flood.
Wow. But I've never thought about this in an astronomical sense, where it is actually changing the rotational speed of a planet.
Yeah, that's huge. Even if it's like these minuscule amounts, I mean, over time, that's going to add up. Not in our lifetimes in any way, shape, or form, But still, to have that that effect on an entire planet just because of just our advancement and technology and not understanding and oh great, industrial age, we can make shit faster, we can make new things, we can utilize natural resources and improve our lives and blah blah blah, and then the time it takes for us to go wait a minute, and then to course correct. Our course correcting of ourselves is in itself a slow process.
Very slow process.
One that is also hindered by our just innate human greed and our own human issues that come along with being human, and our societies that we've created. But I think that's what gets me, is the fact that we have come so far to actually figure out how to use atomic particles to make lasers and tell time, while at the same time causing shit that increases the rotation of the Earth when it should be slowing down because of the moon. Like
we overcame
the moon.
We overcame the moon.
We overcame
not
the moon,
only,
and it's not a good thing. But I'm smiling about it.
Not only did we overcome the moon, we're like, hey moon,
Go fuck yourself.
You're gonna come just a little bit closer to us. We don't want you moving away. Conservation of angular momentum.
Yeah, the moon.
The moon had to move closer to us ever so slightly for that one day. So, I mean, it's just an amazing. The problem with humanity is that we cannot think
beyond ourselves.
Beyond today.
What we want now.
Beyond today, we just can't. I don't know why we can't. Like, I'll be honest. I personally cannot think a generation ahead of me. Because I don't know what the world's going to be like, and I just can't do it.
Too many variables.
The best I can do is probably think maybe a year from now, like the things that I'm doing now, how how that might play out in the next year or two. But that might be the best I can do. And I think that humanity, generally, maybe the best among us, maybe the city planners of the world can go, okay, maybe in about 5 years, this is what things are going to be. But that fucks us. We're smart. Humanity is smart. I know. But we have been able to figure out relativity and quantum physics and atomic clocks and lasers and being able to land something exactly where we want it on another planet. We're smart with regards to that. But we're fucking dumb as hell when it comes to other things.
Brandon has joined us, by the way.
Has he? Oh, yeah.
And he says,
he lost track of time.
Brandon has a real problem with time. He can't ever tell it. So I think we've missed it this year for his birthday. He just had one. So next year for his birthday, I think we need to get him an atomic clock.
Oh, shit.
Then he has no excuses, because that shit keeps tracked down to the fucking millisecond.
So at the University of Colorado at Boulder, they say this is the most expensive clock on the planet.
Why is it so expensive? We just need we just need we need a little bit of we'll get the cheapest atomic element that there is on the market for clock making, and we get a bunch of lasers. They weren't even green. They were red lasers.
Just hit it.
And just, yeah.
Make sure to bring the receipt. Yep. Yeah, we'll do a GoFundMe for this. Cosmos first GoFundMe.
Yeah.
Atomic clock for Brandon. So he knows time.
He can keep time wherever he is in the world.
Yeah, well, at least he joined us.
At the end of this episode, before we go to the hangover.
I really hope here at the end of all things. Take a drink.
Wow, we've been really good doing it. We're so much better with the references.
Yeah, I hope he took his Xbox so that we can Elden later tonight.
Xbox.
But he needs to.
Well, if he took a Switch, we could Mario Kart. But anyway, that's irrelevant.
Oh shit, we forgot to take that yesterday. Oh well.
It's fine. Anyway.
You're in charge of this episode.
I know. The moral of a Flavor size medallion atomic clock for Brandon. It says
best show I ever saw was the Public Enemy show.
Oh my god.
They opened for U2 of all things in Columbia, South Carolina.
Flavor Flav!
And so it was the craziest thing watching all these little people from South Carolina trying to figure out what to do with Public Enemy. You know? And then at the end of the show, they hang this KKK guy in effigy.
Not a real guy.
And I wouldn't care either way. It was the most awesome moment I've had at a concert. Just all these little redneck South Carolina people trying to figure out what to do with Flavor Flav and Public Enemy. It was great. It was great. Best show I've ever been to. Bring us home.
On that note, the moral of the story is that lasers can be used to tell time by vibrating atoms, which is the coolest shit ever. And climate change is affecting the rotation of the Earth, and we should probably fucking get our heads out of our asses. Governments of the world really... one main government in this one. The other ones seem to be kind of more on track.
Well, conservatives, you guys need to get your heads out your ass.
And, so follow us on all the things at Drinking Cosmos on Twitter and Cosmos with Cosmos. Everywhere else you get your podcasts, Spotify, YouTube, Instagram.
I think we ought to talk about time more next time.
Yeah, but now we're going to be heading into the hangover shortly, where we do have a couple special things, some special features that we've been producing as part of our M42 creative stuff that we do for planetariums. And we're going to be highlighting a couple things that have been recently made that are still in progress, but have been recently
join us.
made. So join us there.
I think that's what she's trying to
say. Otherwise, check us out. Keep with us. And next time we'll be talking about something spacey, I'm sure.
Relativity.
Relativity?
Let's do it.
All right. Next episode is going to be on relativity. Mike is going to be having a blast. Relatively.
Okay. All right. I like it. Well done.
And we'll see you next time, everyone. Thanks
Cheers,
for joining
everybody.
us. For those of you with us now on
Stay
YouTube,
safe. Stay healthy.
stick around. We'll be back with the hangover in a bit.
Brandon, we're Eldon on Tuesday.
We'll see you guys in a bit.
Bye.
Be right back.
Hi, we're back.
Welcome back to The Hangover with Cosmos.
Guess what? We didn't even fucking move.
I should have taken
We
a
didn't
bathroom
even
break. I
move.
should have taken a bathroom break.
We started talking about stuff.
We started talking, and then it was like I started the title sequence, and I was like, oh no. But anyway, we're here.
So this might be 10 minutes.
That's fine. I can hold it.
Yeah. All right.
Squeeze.
Go ahead. This is all you.
All right. So for The Hangover, we thought we'd started up front with our little special features, and then we'd talk about whatever we're going to talk about in The Hangover. So if you're with us, as you know, we both worked in planetariums. I don't know if you know that, if we haven't made it clear. And so there's an art show that we used to make for the planetarium that we were at called Art 360.
Okay, all right. Here's the thing. Okay, guys. Art R360, to be honest, was my idea.
Uh-huh.
It was my idea.
Yes.
I did come up with it
On-
with. Go ahead.
At my childhood home on the deck.
No. I had come up with it before.
Oh, that's when we just like.
That's when we
it.
got the first
Okay.
artist.
All right. Oh, Federico's with us.
Hey! And the whole goal was just to take art and marry it with technology and marry it with science. That is my only role in this.
Oh, okay.
Nope, don't do it. It was probably one of the better planetarium ideas that I've ever had, but Liz took it like light years from where I envisioned it. You really did. And so she made it come alive. She gave it depth where I didn't think there was going to be. I mean, I knew there was going to be depth, but she even really brought that out. And I'm really excited for you guys to see what she's done. All right, go ahead. I'm sorry.
All right.
I didn't mean to interrupt.
Okay, so anyway, so it was this thing.
I'm really trying to just say that you've done an amazing job with it.
Thank you. So it was this thing we used to make by taking people's artwork and reimagining it for the dome, kind of making the two kind of come alive, and also highlight the work of some great local as well as not local artists in the community.
Because our first one was not local.
Well, I'm glad, Katie, you approve. So recently, because we do have our own version of Digistar to play with and to make stuff for, not for any commercial purposes at all. And so I've gotten to get back into it. I've started to get back into it. And so for there's an upcoming conference that is the Digistar Users Group Conference. It's for people, institutions that and people that use Digistar to basically come together as a group and kind of, talk about what they do and how they do things, learn from each other, and highlight some of the things that they produce and show in their dome, and the creativity and the great things that other people are doing. And so I thought this year I would finally submit something back in. We can no longer use the title Art 360 that has been trademarked by our former institution. So we have now called it. We've renamed it Art Reimagined. And so there's a couple pieces that I just wanted to give a little preview of that I'm going to be submitting this year. They're still in progress. They're for the most part done. The first one that I'm going to play for you, it is just a highlight of James Webb's first images. It's called James Webb's Kaleidoscopic Universe, and the kaleidoscope effect is something that is kind of like it's a staple. It's a staple of something I use, and I have to have at least one kaleidoscope in any kind of like Art Reimagined piece that I do. And so this is just like all kaleidoscope, and there's some tweaks I need to make to it by slowing down the kaleidoscope just a tad, because in the dome it's a little dizzying.
Well, I just thought it was a little fast.
Yeah, it's a little fast. So these are just kind of in progress, and I thought I'd just highlight them and kind of show them off.
Play it.
For the James Webb one, this one, on our screen, it does show some artifacting, and I don't know if it's going to translate to you guys at all. So, okay, all right. I'm muting us, and hopefully it works. This is James Webb's Kaleidoscope.
by we, I mean you. Hey, we're
All right.
back.
I can see in the lag on our screen that they still got it going. But thanks, Jack. That's sweet. So that was the first one, James Webb's Kaleidoscopic Universe. The second one, it's about 4 minutes. This is more of a true art reimagined piece. This is featuring the amazing artwork of one Katie Davison,
Yeah.
who you may be familiar with.
Oh, by the way, does
on
the
this
music
show.
come through?
Yeah, the music.
Oh, the music should go through.
The
Okay.
music should be going through. I do. I saw the audio bar going, and I did test it earlier and heard the music.
Their pieces. There's like at least like one piece that I just absolutely love in this.
Oh, and Katie's.
Yeah,
version?
and it's and what you did with it and all that, and it. Oh, it
Music
just
works,
okay.
Kate
Good,
confirms.
music works.
All right.
It makes me want to do it a lot more.
I know. All right, so this is the art reimagined of Katie Davison's. I'm just calling it Skulls because she doesn't have titles on her pieces that she gave me or anything like that. So
If you do have titles, send them like real quick.
here you go. Katie, I couldn't, if you didn't have, like, the art that you make, I couldn't do any of this. So, I mean, it's really just me, just kind of going, how would this look cool in a dome? Uh,
It looks really cool, and we saw it. We took it down to my place of employment and saw it on a couple of domes. And I mean, okay, so I mean, there was
there was some
encoding,
issues with the encoding that we did,
but we still, it looked amazing on the dome.
Yeah.
So
Yeah.
even with the encoding issues.
Yeah, it was fun to see stuff that I made on the dome again.
Yeah.
It's been a while since I've seen it on an actual dome and not a flat screen, so to speak. So anyway, that's just a couple of pieces that I just wanted to kind of show off a little bit.
Yeah, and Jack, if you want it, let us know.
Yeah, if you want it, Jack,
you don't
if you want to
run it.
you don't have to.
You don't feel like you have to.
But if you
but yeah, we can.
Are interested at all, then yeah, let us know. Anyway, that's just some side projects that we work on, that we do.
And by we, it's you. I haven't had time to work on it.
I know. I mean, for the most, I mean, you know, this is me getting my feet wet again, kind of dipping back in. It's taken me a while to kind of get back into it. So, and I had a lot of fun with these.
I think I love it. Yeah, there's certain pieces that I really just absolutely love what you did with it, and I love the like just the colors that Katie chose.
Oh my gosh, yeah, Katie's colors were. You know, it's like I can look at her stuff and go, okay, I can see what I can do with this. You know, like I already get a little bit of I can visualize it a little bit. I mean, when we first started doing this, I relied heavily on actually doing most of the effects through Digistar itself and actually scripting through Digistar. But then I kind of, once I learned After Effects more, I kind of gravitated a little bit more to that because it is a little bit faster. But yay, Big Gay Sunday dinner! Bye, Jack. Thanks for sticking around.
Thank you.
Thanks for hanging over.
Yeah, Sunday's the fun day, right?
Sunday fun day.
All right. Have enjoy that dinner.
Anyway,
I'm ready for dinner, actually, but I had no lunch.
Yeah, well, you had a protein bar, and I had some protein crackers.
And that's it.
Yeah.
I will be having more shortly.
Anyway, what was the show about? Time.
What do you want to know about time?
I was just saying, what was the show about? Time.
Oh, it was about time. Yeah. Oh God, yeah. And then if we do relativity next, that's just a mind-bending thing because.
But I mean, at the end of the day, it's all relative.
Yeah, it really is. Yeah, because you know we just don't. We all feel like we all think we share the same time, and we don't.
We don't.
Brandon being on a plane today, his time was going slower for him than it was for us.
That's why he was late.
That's why he was late.
That's why he can't keep track of it. His time is always bending.
Yeah,
his time is always getting whack. That's why he needs an atomic clock.
But
even then.
But if he is like closer to sea level, I don't know where he's going. I can't remember Virginia, but I don't know where in Virginia. You know, it's going to be going even slower for him than it is for us because we're at
but only by
elevation.
Like milliseconds, nanoseconds.
You're talking like
such a.
Nobody notices this, and so yeah, and our brains and our bodies are just not adapted to the relativistic universe or the quantum universe or anything like that. And our brains definitely are not wired to think about this kind of stuff.
Federico says, the length of a minute depends on the side of the bathroom door you're on.
That's where it really is relative, right? So,
Harrisonburg. He's just got to the car. He's got us on the good old. We're on radio.
Oh,
we're on radio, everybody. I don't know what that was. That wasn't.
That was an attempt to a 1930s radio broadcast, like 1930s War of the World.
Oh, you know what? We got to do War of the Worlds. this
Well,
year.
Halloween's coming up. We need Foley artists,
We're
though.
like 2.5 months away.
All right. We'll start putting it together.
Cool.
Was this your idea originally, or was it Brandon's? Brandon wanted to do Lord
Might
of the
have
Rings.
been. Brandon wanted to read Lord of the Rings, but I think we all had War of the Worlds kind of in mind.
All right, why don't we just say it? It's called whenever the closest Cosmos before
Halloween.
Halloween is.
It might be Halloween's on a Monday, so it might be the Sunday before.
Oh, it
depending
might
on-
be. Jesus Christ! Oh my God, they do crazy things here in Utah.
Is Halloween celebrated? Federico, do you celebrate Halloween, or is this like an American thing? I really don't know how Halloween works.
It's not an American thing. I mean, Ireland did a lot of shit with it.
Okay.
But anyway, so here's the thing, though. This is what
Anyway.
we discovered last year. Welcome to The Hangover, everybody, because this has nothing to do with anything.
That's why it's the Hangover. It's just
So last year, Halloween was on a Sunday.
oh my God.
And so
You think it'd be great.
we get all our candy because we go crazy with the candy because we get it for them, we get it for us.
Yeah, most of it's 90% of it's for us.
But we and it was a Saturday. The 30th was a Saturday, so we've made our drinks. We're watching TV, doing all this kind of stuff. And then we start getting knocks on the door, and it's people coming for Halloween.
And we're like, you're a day early.
You're a day early, and they're like, no, we do it. If here in Utah, if Halloween falls on a Sunday, they do Halloween on a Saturday. First of all, broadcast that shit for new arrivals to Utah.
People that aren't.
But second of all, that's not how you do it.
That's not how it works. Halloween is on Halloween. Anyway.
Oh, it's American stuff.
At least for Italy. They're now used to
Candies are
celebrating.
candies.
Candies are candies. Look, it really, this is what it is. Adults were like, we need an excuse to eat candy. Halloween.
Yeah.
Let's make Halloween. Mexico has Dios de los Muertos, but that's in
That's not-
September.
Sure.
Or I can't remember what
September
date it
9th,
is.
as we've discovered with all the things that we
Anything, yes. All murders happen around when I was born. But that is not technically. That's not like a Halloween though. It's more of it's like a celebration of your ancestors and that have passed, and it's kind of like just a big
What was that
celebration of
movie?
life and death.
Wasn't there a movie, a Pixar movie?
Encanto.
Encanto. I've never seen it.
Encanto, but it's supposed to be
I
really
haven't
good.
seen it. Yeah.
November 1st. Okay, November 1st. So the day after our Halloween.
Oh, wait, All Saints Day. All Hallows Eve is All Saints Day. I mean, All Hallows Eve. November 1st is All Saints Day.
Oh.
It's a religious fucking
Right,
holiday.
okay. Catholics are just like, we need to
Oh,
compensate
or
for
Coco.
demons. Oh, Coco. And Canto's the dancing one. Coco is the Dios de los Muertos one. That's right. Okay. Thank you,
No, it's a religious holiday. I don't know what the fuck they celebrate. Saints?
Saints? All of
Yes,
them.
all
All
of them.
saints.
All
All
of
of
them.
the saints. It's All Saints Day.
All Saints.
Or it's just a big day for the
Do they?
New Orleans.
What about do they do like Satan saints?
Do Satanists have saints?
I'm sure they do.
Are there satanic saints?
Demons. I don't know.
What is happening here? It's sad without candies. You have to have candies.
What? People have what? Wait a minute. What? There's Halloween without candy?
You gotta have
that's
candies.
It's gotta be.
I mean, you can't.
Internationally illegal.
You can't have. I mean, you gotta have your Reese's. You gotta have your Mr. Good bars, your Smarties.
What's the one with the peanuts in it? It's like the.
It's the Mr. Good.
Is it Mr. Goodbar with the peanuts? Mr. Goodbar has peanuts.
Mr. Good Bar?
Yeah,
Yeah.
so it's like Hershey's with peanuts.
Yeah.
Oh, I love those.
Yeah. My grandpa would have Mr. Good Bars all the time.
Those are always good.
So I love those.
Yeah, it's
We're 2.5
Halloween's
months away
coming
from
up.
Halloween, so
Halloween's
I'm
coming up.
ready
Can't
for
wait.
it.
Do you guys have your themes? You need to have your themes. You need to dress up. We have our theme. We know what we're gonna. We don't know. We know our theme. We know our theme.
Vampires.
Why you gotta tell everybody? Vampires. Our theme's gonna be vampires. Sparkly vampires.
Oh, Federico means 1st November is the day of the ones past, and they usually celebrate by visiting graveyards, but no candies or parties.
Oh, but
Dude,
don't.
bring candies to the graveyards.
Yeah, they want you to
Dead
have
like
the candy.
candies.
Dead like candies.
When I die, I want candy in my graveyard. Don't bring me flowers. Bring me candy. Reese's Pieces. Just scatter them all over my grave. I'll get them.
You know what they need to do? They need to drill a hole down into the coffin.
It's a Reese's Pieces
Drop
hole.
them down in there.
Just, they dig me up 1,000 years later, and it's just like a tomb
Just
full of
nothing.
Reese's Pieces amongst skeletal remains. But I want to be a mummy, so.
But I get them too because.
Oh, we watched Day Shift last night too, Mom.
I mean, what did we watch?
Mom watched Day Shift last night.
Oh shit! Yeah,
We
that
did
was
too.
great.
We were doing the exact same thing as my parents. We were watching Day Shift. It was pretty fun.
We should have gotten on
We could have
Zoom
done a
or
watch
something.
party.
Yeah, watch party.
Oh my god, what a hangover. This is a wild ride. We're not going to last
We-
53 minutes.
We
Brandon.
haven't even talked time.
But what is time? I mean, if you think about it,
Relative.
we've made up time.
No, we haven't made up time. It's the fabric of the universe. Literally and figuratively. Space-time.
But how does the universe tell time?
Well, we don't
It doesn't
understand
use
it.
numbers.
We don't understand
We
time.
made up numbers.
Well, no, the universe made up the numbers, and we. Oh, you're talking about like what a second is and that type of thing.
Yeah, so like, I mean, if you have like an alien species, 100,000 light years away, they're not going to have zeros and ones, most likely.
Well, they're not going. They will have a concept of what 0 is and what 1 is, but they're not necessarily going to break their day up into 24 hours. That is really seems arbitrary.
Yeah.
So 360 degrees seems like an art. If you're gonna say 360, you might as well say 1,000 degrees. In a full circle. But I don't know how the Sumerians or the Egyptians came up with 360 degrees. But the 24-hour clock. I mean, yeah, it's.
I mean,
It's
that
kind
that
of
is
all
based
arbitrary.
on like when we're awake and when we sleep, and
Yeah, and so
you know.
yeah, so an alien species is not going to break their day up in 24 hours. That's what's so crazy about like Star Trek and Star Wars is that they break their days up in 24 hours and shit like that. And
Yeah, when they're on the Enterprise and like, oh, I'll see you tomorrow. Yeah, it's like, what is, when is it afternoon?
Yeah.
How is it nighttime? What?
yeah, and I have another question for you Star Wars and Star Trek producers. Why aren't the aliens, quote unquote aliens, from another world, why are they not either wearing night vision goggles or sunglasses?
Oh yeah, you're hung up on the sunglasses.
I am. I mean, it's just simple things. The simple things. You live and die by small
Maybe
details.
they got like like they have the translators built in. They got like eye things built in so that they can.
Yeah. Okay. All right. So 360 divided by all these numbers.
But we've made up these numbers.
Well,
Like
no.
we've just made them up.
No, one is kind of a fundamental thing. I think if you were to go to another planet and another species, you would be able to communicate with like the ones and the zeros and the twos because they're very definite things. Like you could hold up two rocks on Mars to a Martian and say 2.
There are no Martians.
Okay, but if there are, you could hold up 2 rocks and say 2. Our common language with an alien species
Is math.
is math. And math is built on
squiggly
zeros
lines
and ones and
and
twos.
Greek
But it
letters.
is also these squiggly little letters and stuff like that. And so that is our common language. And so there is a definite 1 and a definite 2 and definite 0.
Yeah, well, the Mayans were the first to be like 0.
0. And it's yeah, and so I think that whereas 24 hours might be an arbitrary thing, that 0 and that 1 and that 2 and those numbers aren't.
Okay. And using things like base 10 and base whatevers and stuff
Yeah.
are going to translate to...
And to be honest, this is why the metric system makes so much sense, is because it is based on 10. The United States,
Like what's our bullshit based on?
and a thumb. I mean, and it's just.
Fuck logic, everybody. We're American. We're gonna base an inch on the length of your thumb.
Yeah.
But just the top part of your thumb.
And you know
the
what?
First knuckle length.
And you know
it's
what?
Not the same.
We're gonna go with mine. Whoever has the. Because I'm a male.
Whoever's got the biggest thumb knuckle that's our basis of measurement.
So I mean. Yeah, the metric system makes sense. The metric system makes sense. And our whole entire argument for not going metric in the United States is because it's European.
Oh, God.
And it's European.
I mean, but I can't figure it out because I can't figure out anything with numbers and
Federico, I am sorry, but this is the mentality of the United States. And it is seen.
We fought a war not to be European, so by God damn it, we're not going to use any European shit. Forget socialized healthcare.
But
forget recycling.
I guarantee, but we do recycle.
I mean, we recycle.
But I guarantee you that, if we were to go to Ted Cruz, if we were to invite Ted Cruz to this podcast, and we were to say, yeah, it does rule, Federico. Fuck yeah, it does. Oh my God, I wish we were so due to the metrics. Anyway, and we would bring Ted Cruz.
But we'd have to rewrite all our textbooks.
You know what?
Christians write those. They don't want to rewrite them.
I'm going to tell you right now, science textbooks already use the metric system. They do not use feet. They do not use the imperial system.
Every time there's something and it's like kilometers and meters, and then I have to look at him and I'll be like, what's that in feet? What is that?
So, if we were to invite Ted Cruz here, he would say that the metric system is socialism. And it's just like, how do you make that fucking leap? How do you make the leap that it is socialism?
So the metric system...
Yeah.
It takes away your freedoms and your individual rights and your personal.
Yeah, because anything that is European, and for the Ted Cruzes of this country, is socialism. And the problem is that in some regards, this country is so woefully uneducated that large swaths of the populations believe it. They believe it. They will believe that the metric system was invented by fucking Karl Marx. And it's a communist plot to take away your freedoms. And Canada fucking uses it.
Who doesn't use it? Just us?
The U.S. I mean,
is
the
there
number
anybody
of
else
countries,
that uses inches?
Oh, I'm sure that there are, but most of the world uses the metric system now because it's so much easier to use. Everything is based on 10. Mm-hmm. And, you divide by 10, you multiply by 10. Everything is based on 10. As Americans, we just have to get used to the fact that I'm just going to use 60 miles an hour because it's just easier to use. Mm-hmm. That 60 miles an hour is the same thing as 90 kilometers per hour.
But it sounds like you get to go faster. What is inches? What's inches in?
It's in centimeters. So 2.5 centimeters roughly is equal to an inch.
The centimeter sounds smaller.
Because it is smaller. But a meter is a little bit larger than a yard. The problem with the imperial system, which is what we use...
That's ironic it's called imperial when...
yeah, is that it's just so arbitrary. It makes no sense.
That is America in a nutshell. Arbitrary.
I can understand way back in the fucking day where you're like, hey, I'm just going to use my thumb knuckle, to measure.
That's about right.
To measure the length of this fence, and I'll just go boom, boom, boom.
Let me walk out with my feet and see how many feet.
Yeah.
How many of my feet I need.
Oh, you know what? I'm just gonna put 12 of these together. Even 12 is an arbitrary number. It seems almost biblical to me that you choose 12 and not 10.
Are there 12 apostles?
There you go.
That's what
Maybe
it is.
That's where I'm getting it from.
12 is based on the amount of apostles.
But 10 is just so much easier to multiply and
Yeah, if I need to do any math, I'm looking for those even numbers. I'm looking for tens. I'm looking I can multiply. I can
multiplies.
4 times 10 is 40. Like I can do that real easy.
Mm-hmm.
But if I go 4 times 12, I don't know. Then I gotta
48.
be like, all right. But I have to be like, all right. Well, 12 plus 12 is 24, and then I gotta go to 24.
You know what you can do? You know what you can do?
Is 48. So that's how long it takes me.
All right, you can go. 4 times 10 is 40.
No, you're adding too many steps. I can't. You've already no, because then I gotta add more. I gotta put more numbers in there that aren't. That don't need to be in there, and it just
12 is.
God, I'm glad I
don't
did
know
not.
what that yellow bar means, but 12 is 10 plus 2.
Oh, we're buffering. We're buffering.
And so
we're
4 times
lag.
10 is 40. 4 plus 4 times 2 is 8. Yeah, I'm 48. Boom. Bam, boom.
Anyway, my math skills are not good, and it's probably due to the imperial system. I'd probably be better at math if we had the metric system. So we should be European and be smarter.
We need to be European on other levels.
So many
things.
Education, healthcare, abortion, all the things.
Yeah, healthcare should never be for profit.
No.
Ever,
No.
ever. But are we down?
No, we're just getting some buffering. So anyway, I think that's
Are we calling it a day?
I think that's a sign that we should probably wrap it up if we're getting some lag. Probably due to the heat.
All right. Well, anyway, thanks for joining us, everybody.
This is a wild hangover.
We didn't talk about time at all.
Well, we talked a little bit about time.
We'll talk about it more with relativity.
Yes. So our next episode in 2 weeks will be on relativity. Mike's gonna have a blast. If Brandon's not on assignment, he will be hosting it. If he is on assignment, Mike will be hosting it.
So I guess I'll do all the talking.
I'll jump in there with some witty puns and some weird questions and.
I do expect relativity puns, so you have 2 weeks.
Everything's gonna be relative. I don't know what.
You can use that one. You have to come up with other ones. We're going to have to come up with other ones.
We'll see.
Oh, your mom's already checking out.
She's like,
bye, I love you guys. We're out.
Anyway, thank you guys so much for joining us on another episode of Cosmos The Hangover. Thanks for watching our little art pieces that we displayed. And
join us in 2 weeks. Stay safe.
In 2 weeks. Follow us on all
Stay healthy.
Things. And we'll see you next time.
Cheers, everybody. Peace.
Bye. I was going to say something in Italian, but I don't know.
Oh, don't do that. Please don't.
I can't remember any
Italian.
Don't
do it. Don't do it.
I don't want to offend Federico with my American bullshit.
Was it ciao?
Ciao. 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 I was going to say adios, and I'm like, that's Mexican.
No. Ciao.
Ciao.